So what is Azure Front Door? So Azure Front Door is a global content deliverable delivery and acceleration. So this is about global content delivery and acceleration. So in that, uh, so for global content delivery and a good acceleration of data, we use this Azure Front Door. Azure Front Door, by definition, it says Azure Front Door is a Microsoft's modern cloud-based content delivery network. It is a modern cloud-based content delivery network. I was talking about CDN yesterday, right? So this is
Yes.
CDN, Content Delivery Network, that accelerates delivery of static and dynamic web content. So here accelerates means it will be a faster for the users to access this kind of data if his friend door is implemented. The key functions are Microsoft Global Edge networks are used here for optimizing routing and fast content delivery. So there will be a global edge networks. I'll be showing you what are these global edge networks. So we'll be using them here for the content delivery network. The performance, when it comes to the performance, it will be speed and reliability will be there, and availability, high availability will be there throughout the world. Global reach, so leverages numerous point of presence. So point of presence located close to end users. So I have a separate slide for point of presence. I will explain you in detail on what is this point of presence. Security, so it has a built-in DDoS protection, SSL offloading, and WAF integration. So this is secure socket layer, offloading is there, and WAF. So we use SSL certificate, for a handshake to go to into the network and get the data. So this kind of protection is there. The security protection is there for Azure Front Door. So point of presence. So this is one important thing you have to mention when somebody is asking about Azure Front Door. Azure Front Door has multiple point of presence uh, throughout the world. Okay, each metro city may contain this point of presence. Currently, Azure Front Door has 192 edge locations across 109 metro cities. So apart from these regions and data centers, there are some point of presence from Azure are there. In total, 192 edge locations are there, which are serving the end users who are accessing or who are using Azure Front Door or the Azure services. Azure Front Door also includes 4 edge locations across the 4 Azure US government cloud regions. So there are 4 locations which are used by US government. These globally distributed POPs allow traffic to be served from the closest edge location. So these distributed POPs will allow the edge users to connect to the local edge point of presence and access the data. So there will be reduced latency and improved performance. This link has, so I kept this link here. This link has more details about where the POPs are, point of presence are there. Let me click on that, open and show you. Azure Front Door POP locations by metro city. So there are, as I said, there are 192 edge locations and across 109 metro cities. So it also says Front Door also has a 4 edge locations across 4 Azure US governments. So Canada, 2 are there. A location might contain more than one POP noted by the number in parentheses. So that means that there are 2 point of presence in this region, Canada. Similarly, it has listed the different regions where the point of presence are there. This is from North America and this from South America. Even the Europe region has multiple point of presence. Africa. And in India, we can see it is available in Hyderabad. Chennai, it is there in 4 regions. I mean, the 4 POPs are there. Mumbai 2, New Delhi 1. Asia, we have the different, in Asia, there are these many are there. Australia, New Zealand. And the Azure government edge locations, which we were talking, right? There are 4 of them. But surprisingly, I see only 3 of them here. Maybe one is not listed, maybe security reasons, or I don't know. Only three are listed, but in the same page they mention there are four of them. If I go up, it says four edge locations. So these are the point of presence located. So these are apart from the regular Azure regions and regular data centers. 192 are there. So that is kind of a backbone for Azure Front Door. So I have taken a Indian postal system as an example to explain Azure Front Door. So what is happening? Indian postal system, we have a head post office, then a region post office, then a local post office. Suppose the head post office is in New Delhi, then a regional post office is in Hyderabad, and local post office is in Amirpet or Kukatpalli. You can also take in this way. The head post office is something in Hyderabad city, then in one of the district, then in a village. Okay. So what is happening? The main central post office where mail originates. I am trying to send a email to my village. First, what is happening? The mail goes to the head post office. Then from there, all the emails are coming there. All the posts are coming to the head post office. Then they are getting distributed to their regional post offices. From there to the local post offices. And the postman is delivering these mails or the data to the village, to my relative who is there in the village. The first time, the post office may not know where is the address. Generally, in villages, if you see the postman, they know everyone, so they just go and give, right? So that is kind of, you can take that as a cashier. So he first time he may not know, but over a period of time, he comes to know, okay, this person is there.
Okay.
So that is kind of a cashier. Okay. So here, head post office, the main central office, you can take as origin server or main data center where your web content is hosted. Head post office, server or main data center. That means I have hosted my web application or a storage in East US that will that has the data. So from there, what is happening? Point of presence or edge location. So from there, it is going to the regional post office, the point of presence. Okay. And to the local post office, to the village post office, like edge node closest to the user. It is going to that. So next, sorting and routing system determines the fastest route for your letter to reach the destination. So sorting and routing system, it's like the pin code we have, right? We know from pin code, okay, this is where it has to go. So that is the shortest path. If I am sending a email and it has to go to one of the village in Telangana, if it is going to from New Delhi, it is going to Bangalore, then to Chennai, then it is coming to Hyderabad. It is not the fastest route. It is a long distance, right? So the shortest way is come directly to Hyderabad, then go to the village. So that's the distribution, right? So it should know the point of presence or the regional post office and the local post office. Speed post or register post. So when I send register post, right, I get a acknowledgement, okay, and I also can track whether it has reached. Once it is reached, I get a message, okay, it has reached to my relative. Okay, so ensure secure and trackable delivery. So this register post has security and trackable delivery. And I'm sure when I do a register post, I'm sure that it will get delivered and I can track where it is. So similarly, in Azure Front Door, we have WAF, SSL, and DDoS protection. Suppose if one post office is closed, mail is rerouted through the next available hub. So if my village post office is closed, like there is only one postman in the village, and he is on leave. Then what happens? Uh, there is a neighbor village. There is one postman, so he can deliver that to the village, to the nearing village, right? So that kind of rerouting can be done, but from the nearest one, automatically fail over to the next healthy pop if one location fails. Uniform service experience, whether you are in Delhi or Bangalore, letters reach quickly and faster. Consistent performance and security for users globally. So this is a Indian postal system example for Azure Front Door. Basically, here the takeaway is that there are different point of presence and edge nodes. Here it is a local post office, and here we have edge nodes. They are actually serving the users who are near. So that's a takeaway from this example.
Got it.
Yeah. So here is one more thing. So uh, origin server. Here origin server is nothing but my app service or the storage where I have kept some of the videos or PPTs or whatever it is, images or that I have kept here. So what is happening? This origin group can have two or three Azure resources, two or three Azure storages. So this origin group and this is origin server. Similarly, this is one more origin group and this is origin server and origin server. So what is happening? The clients are there who are trying to access the data in the origin server. So basically, the client has to take the information from origin server and he should access it basically. So it is like the request should go till here and come back. So what is happening in this case? So the client first is trying to browse a URL. The URL is so the CNAME record will be there that get resolved, and CNAME record is getting resolved to the friend or CNAME. If it ends like similar to FD, like yesterday we have seen traffic manager, right? Traffic manager.net. Similarly, friend door will have some URL. So that gets resolved to this Azure friend door. Azure friend door will have point of presence. Okay, the point of presence, it takes the nearest friend door point of presence, then it does a DDoS protection. So it goes through this. Then I have this custom domain which is getting resolved. Then there is a TLS certificate. So this has this TLS certificate, transport layer security. So at this layer, the data has to travel through this gate. There is a security check at the transport layer. So you should show one certificate or a gate pass like that. Okay, I have this certificate. Let me allow inside. So once you show your certificate or once you bind your certificate to the request, it has this origin servers has this certificate. It passed through the WAF, web application firewall. This works at layer 7. Transport layer TLS works at layer 4. WAF works at layer 7. This is a
Layer 7.
yeah, application layer. This has again some set of rules, allow only these requests, deny these requests, drop these pockets and packets and all. So it goes through that. Then the request will check in cache. This is important. The front door, the main use is cache. Okay. So this cache, it will check is so these kind of requests did I served before? If yes, I have some data, then what it does, the request will be served from cache itself to the client. If not, there is a new request and in the origin server also there are some changes related to that request. What it does, the cache will connect to the origin group and to the origin server. It gets that new data and saves it in cache so that if some other client is coming with the similar request, it can serve from cache. So this happens in point of presence, right? The point of presence is very near or the local post office, like a postman here. He knows what needs to which to whom I should deliver. So such kind of cache will be here. Okay, so this is how it works, and it has some compression. So the cache will be there will be a compression, and rules are there, engine rules and routes. So in Azure Front Door also there are routing rules. Okay, so the overall decision flow is like this. The routing rules are like this. So available backends, priority base, latency, weights, like how we have seen yesterday. But traffic manager, similarly, we have the routing rules. Basically, this is a logic, to get the data. from origin servers to POPs.
Okay.
Okay, yeah. Here, the first one, we'll go through this first one, available backends. So in this example, C is unhealthy and end is E is disabled. So A, B, D, and F are available to serve your requests. So basically, four of them are trying to serve your requests here. So basically, if they are healthy, the request will go to one of the origin servers, and it will serve your request. So based on availability backends, it will serve. The next one is a priority based. So A, B, D, and F are there now. Out of these four, one, two, three, four. So I have given priority for priority one, and this is two. So origin A, B, D have priority one, and origin F has a priority two. So selected origins will be A, B, and D. So out of these, three of them will go and serve the request because they have the high priority. That means the number is low. Next will be out of this A, B, D. A, B, D has one, right? Out of these, 15 milliseconds, 30 milliseconds, and 60 milliseconds, right? There is a latency based on health probe. So out of this, whichever is low latency, that will serve the request, 15 milliseconds. So now now A and B are there, which are low latency below 30 milliseconds. Then the weights will be there. I have given weight like 3 and 7. Then what happens? The higher the weight, higher the priority, right? Or it's like 3 into 7. Out of 10 requests which are coming, 7 requests will go there and 3 requests will come here. So that's how the traffic is getting going. Uh, and the end origin servers are taking the request.
Got it.
Each
So
layer,
this three is to seven ratio we usually put in as a weight, or it is automatically calculated?
we put in this as a weight.
Okay.
We add them as a weight. Yesterday we have seen 50 and 5, right?
Yes, yes, yes. Yeah.
Yeah. So in that way, I have provided the link, so you can go through this link. This link has some more details about how this is working. But overall, in this page, you will see this diagram, and they try to explain this. So this is a
Okay.
decision flow. So there are multiple origin servers, how the decision is made to which origin server it has to reach. So it's up to you which one you are, which routing are implemented. The next example is this one. This is another flow. So here here the origin server is Azure Storage. So what is happening? Here is a client, and we have a front door, and front door has a WAF, and here is a cache. So the feature of Azure Front Door is cache, right? So it has a cache. And here is a storage, and you see here is a private endpoint. So front door is connecting to Azure storage using the private endpoint. So the first step, what is happening? The client establishes a secure connection to Azure front door using a custom domain name and a front door provided TLS certificate. The connection terminates at a nearby front door point of presence. So it is reaching out to the nearest point of presence. Azure Front Door Web Application Firewall scans the request. So WAF will scan the request. If the WAF determines the request is too risky, it blocks the request and returns an HTTP 403 error in response. So if WAF determines if the request is too risky, it will drop the packet here itself, or else it will forward the request. If the front door pops cache contains a valid response, front door returns the response immediately. So the client has requested something and the cache is having that request response, then it will immediately respond back with the request with whatever the data the client is requesting. If not, the POP sends the request to the origin storage account using Microsoft Backbone Network using a separate long-lived TCP connection. In this scenario, private link securely connects to the storage account. So here, if cache doesn't have the response, then it will forward the request to the Azure storage using private endpoint and TCP connection. As we know, TCP is a transmission control protocol. It makes sure that requested data, everything it receives. Even if some packet is not received, it will tell the destination that I have not received this packet and make sure the destination origin server sends that packet. So it uses TCP here. So once it cache receives back the request, the storage account sends a response to the front door POP. The POP stores the response in its cache for future requests. So the POP stores the response in its cache for future requests. This point is important. So it is saving the response in its cache for future requests. The POP returns the response to the client. Any direct request to the storage account through the internet get blocked by the Azure Storage Firewall. So here, any direct requests are directly, they are blocked. It has to go through the Azure Front Door.
Got it.
So this is how the
So,
front, yeah, go ahead.
so it's gonna be having the cache. That's why the response time would be faster. That's the reason, right?
Correct, exactly. This point of presence, they maintain cache.
Yeah, got it.
So if you see this point 6, that's what it is trying to explain. The POP stores the response in its cache for future requests. So if it is a new request, it will, it will send to Azure storage, then puts that in the cache.
Understood.
Now let's see what are, which one we should be choosing, um, which load balancer solution we should be choosing for our scenario. So we have seen application gateway, front door, load balancer we have seen, traffic manager we have seen. So this particular table will explain us what is the difference between each one of them. So now let's see the feature usage. Optimize delivery from application server forms while increasing application security with a web application firewall. So it supports web application firewall and it uses protocols HTTP, HTTPS, HTTP2. Similarly, the front door scalable, security enhanced delivery point for global microservices based web application. And this has internal support, this doesn't have. And both of them, they are using the same protocol. But if you see application gateway is not cross region, but whereas front door is cross region, it can support the cross regions like one origin server, one app service is in East US, one is in Europe, like that. Even in those cases, this will serve front door, but this won't support that cross region. Environment, Azure, non-Azure cloud, on-premise. It can, um, you know, it has this feature to, accommodate these. And front door, it has the similar feature. These all environments, both of them support. Security, WAF, here WAF and NSE. Coming to this load balancer and traffic manager, balance inbounds and outbound connections and requests to your application or serve endpoints. It uses TCP UDP protocol. Traffic manager can use any. So this will distribute traffic optimally to services across global Azure regions while providing high availability and responsive. And this will use any protocol. And internal support, yes, it supports internal. It won't support cross region. It is still in preview phase. So that means they are trying to support or give, this feature is getting added for cross region. I think by now it might have, it may not be in preview. This may be yes. This needs to be checked once more. I mean, I need to check this again if it is in preview or already implemented. Traffic manager supports cross region. environment it supports is Azure. This supports all Azure, non-Azure, on-premise. Load balancer. Here security is NSG. Traffic manager doesn't have anything. These are some major one. And I have this link. Let me open. Mm. So this is one good chart or the flow diagram. So here you are starting. So if you are given a task to choose a load balancing solution, you can go through this flow chart. You start from here, web application. Yes, I am using web application. Then you have to come down. No, I'm not using web application. It is not a web application. Then internet facing application. Um, no, then use Azure Load Balancer. Like Azure Load Balancer will support VMs and VMSs. That's all. Internet
Got
facing
it.
application. If it is S, then then you can use Traffic Manager and Azure Load Balancer. If it is internet facing application, then hosting only APIs. So you are hosting only APIs. The backend, it is a backend application. It has only APIs. Then you can either use API management or application gateway. So similarly, you
Okay.
can go through all this. So global deployed in multiple regions. Do you require SSL offload or application layer processing per request? If yes, then go ahead and use Azure Front Door plus application gateway. If not, only APIs I'm using, then go with Azure Front Door and API management. If not, then go for this the only PaaS service you are using, like app service and functions, go with Azure Front Door. If you are using AKS, then go with Azure Front Door application gateway, ingress controller. If you are using only IaaS VMs, go with Azure Front Door and Azure Load Balancer. Similarly, it is your um, deployed in multiple regions. If yes, do you require performance acceleration? So if yes, then you go back here and you can choose one of them. If no, deployed in multiple regions, no. Here it is no. It is not deployed in multiple regions. Use application gateway or application gateway plus API management. So these all um, are going through the flow based on the table which I was showing. So it internal support or cross-regional support, which environment, which protocol. So based on the features and the routing methods, everything taking everything into consideration. So this flow chart is there. I've put this link in this slide. I will share you. So if you come across any situation where you are asked to choose a solution, then go through this flow chart. This will be very helpful.
Sure.
So there is one lab. Mm, okay, and I was trying to check on the lab. Mm, So what is happening? It is trying. So these are the sources and front door he is trying to create. And in central US, he has created one web application. East US, he has created one web application. The one you are seeing is a ASP, Azure App Service Plan. App Service Plan. To the front end, origin servers are the central US one and the East US one. So here you have to choose custom create web app instances. You here is creating two web apps, then he is trying to create the front door. So let me come here, open front doors. So here in the global search, once you type front door, you get this option, services front door. So this is part of load balancing and content delivery. So this is one among the other four: application gateway, load balancing, traffic management. All you can see here. Click on Azure Front Door, create Azure Front Door. Quick create, you get an option quick create and custom create. I will choose custom. So to work on this or create Azure Front Door, you should have Microsoft.cdn registered for the subscription. I don't have this registration, but how you can create is it is a simple step. Okay, just give the name, resource group, profile, and tier. You give then secrets. If there are any secrets, you can add endpoints. Endpoints is nothing but the origin servers where you can add here. You can add the endpoint, the app service endpoints. That's all. Then review and create. So, so these are the basic features which you need to add. Basically, the endpoints you need to add to the front door, then it will start working. So this is all about Azure Front Door. I'll go back and I'll start the next one, Network Watcher. This is just a tool and a small topic. It won't take 5 to 10 minutes, more than 5 to 10 minutes. Mm, Azure Network Watcher. So what is this Network Watcher? Uh, so organizations can use Azure Network Watcher to detect and monitor issues related to the network performance of infrastructure as a service. So organizations are using this watcher to detect and monitor issues related to network performance of IaaS services. Network Watcher provides a suite of tools. So basically, this Network Watcher has a suite of tools like monitoring, diagnose, view metrics, enable, disable logs, and all these they work for IaaS services. Network Watcher enables you to monitor and repair the network health of IaaS products like VMs, VNets, application gateway. And one more thing to remember is that Network Watcher is not designed for PaaS services like app services, AKS, all these things. It won't work for them.
Okay.
So Network Watcher consists of three major set of tools. So this Network Watcher, this capability has, I mean, it has these capabilities and these tools. So once you open Network Watcher, you will see connection monitor and topology, which are related to monitoring, network diagnostic tools like NSG diagnostics, IP flow verify, effective security rules, packet capture, VPN troubleshoot, next hop, connection troubleshoot. These are part of network diagnostic tools. I will try to show all of these in the portal. Next, to check the traffic, you have the traffic analyzer, analytics, and flow logs. So how Azure Network Watcher works? Azure Network Watcher becomes automatically available when you create a virtual network in an Azure region in your subscription. So I created a VNet today in East US region. As soon as I created a VNet, it went ahead and it automatically created a network watcher in East US region. Similarly, when I created a network watcher in Europe region, apart from this VNet, I can see a network watcher got added for Europe region. So two VNets are there in two regions. In the same at the same time, two network watchers are added. So basically, these network watchers are a region specific. As soon as you create any VNet in that region, a network watcher gets created automatically in the background.
Got it.
Yeah, network watcher directly, you can open network watcher directly like this, just type network watcher in the global search. You can see here and you can open and access the tools and capabilities. And when to use this network watcher? Azure Network Watcher is useful when you are attempting to troubleshoot networking issues related to Azure IaaS products. For example, you can use the tools included in Azure Network Watcher in the following scenarios. In the following scenarios, you can use one, resolve connectivity issues related to IaaS VMs. So when you are trying to troubleshoot connectivity issues between the VMs, you can use. Second is VPN connection issues you can use. And if there is a network latency between two different regions, cross regions like here, West US and East US, in that scenario also, you can use Network Watcher.
Okay.
So on the portal, how I can open is once I type Network Watcher, it comes up. So you see Network Watcher East US, Network Watcher West US. That
That's
means
you.
I have two VNets. What I have done, I have created two VNets, East US and West US. East US and West US. So I have the watcher in these two regions. And apart from the VNets, I also created VM inside those VNets just for testing some of these IP flow, all these things. So once you click on the topology, right, it shows West US and East US. So what I've done, you see a line here, right? West US to
Yeah.
East US. There is a line. That
You
means
establish a connection between both of them, then it connected the line.
correct. So we have this concept called connectivity, right?
Yeah.
So I did the peering basically between
Yeah.
West US,
Region peering.
yeah, regional peering, so that the West US VMs can communicate with East US VMs. I established peering then, so this line it has shown. That means that there is a communication happening between these two regions using Microsoft backend network. Okay, next is connection monitor. So this is one tool which you can use, connection monitor. Once you click on connection monitor, I will say this is a connection monitor CM1, then test group. So here it is giving, I'm trying to monitor the connection between two VMs. As I said, in three scenarios we use, right? So here we can check the connection between VM1 and VM2, which are in two different regions. I will add source. East US is East US, and this is one VM in East US. Okay. And I will say add endpoint. So this is added in the source and destination West US. I will add West US. In destination, you can choose East US also. Like if there are more than two VMs or there is another VNet which is in the same region, also you can choose. You are just trying to check the connection between two different resources, whether it can be in the same region or in a different region. But here now I will select a VM in a different region just to check the connection. So I added source and destination. Now I need to add test configuration. I will name TC1. This is the name of the test configuration. It will send a HTTP protocol. Destination 80, destination port is 80. Frequency is 30 seconds. And it uses a basic path slash, and it uses a get method to check. I'll just add, I will not add anything. Add configuration. So now it has TC1. So this I need to name TG1 add test group. You can see this test is now added TG1 and source is East US VM and destination is West US VM. And estimated cost to check is $0.3 per month. So these kind of um, test groups or connection monitors we create when there are critical resources. We want to monitor them continuously, that there is a connection and the packets are flowing between these two. continuously. In that case, we create this connection monitor.
Got it.
Yeah, and traffic analysis. So here I did not create log analytical workspace. Log analytical workspace is a workspace. Once you create a workspace, there it shows, saves the logs. If you want to check the NSG logs, so what all the NSG logs you can check here. Okay, you can choose the NSG or VNet and the flow logs. So whatever the traffic or the packets flowing through this VNet or NSG, you can you can check or you can do analytics from here. So for this log analytical workspace is needed. You can we can create and use it. IP flow verify. So this is monitoring part is done. This is network diagnostic tools. IP flow verify. So here, so network interface is this TCP UDP. I will say this is in East US. I want to check something. Let's say port 80 and remote IP is my VM, which is in other region. I'll say 0.4 and remote port, I will say 80. So once you click on verify IP flow, internet protocol flow, that means it will send a packet and check whether you are able to make the connection. The packets are flowing or not. Access is allowed, so you are able to access, um, and the packets are flowing between these two resources that you can check. If I type like I will say 8.8.8.8. I believe you are aware of this IP. This is a global
Yes.
DNS server, right?
Yes.
So let me check whether these VMs are able to access internet or not. I mean, this VM, particular VM, is able to access internet or not. I want to check. So it says access is denied. Why it is denied? There is a security rule, deny all inbounds.
All in bar.
So basically, it doesn't have access to the internet. Okay, next is NSG diagnostic. So this diagnostic is used for network security group rules. So East US, then I will say protocol any IPv4 CIDR 10 dot destination port 80. So this particular one is traffic will be allowed if all NSGs allow it. Traffic status denied. This NSG is blocking, um, is applied on this and it is denying the flow. Okay, that's what it says. If you click on additional details, it shows. So this one is not matching and this is where it is getting denied. So basically, you are given a task to check, uh, like your team and some other team are working. Okay, and your application is being consumed by another team application and they are saying that they are not able to access your application. Then what you will do, you will put your source here, that is your application IP address, and in the destination you will ask them their IP address. Then you will put those, give those details here. Then you start NSG diagnostics. You have a doubt that somewhere NSGs are blocking this. So once you do that, NSG diagnostics will tell you where exactly it is getting blocked. So it says this is not matching, this where it is blocking. and this is not matching, and that's where it is getting blocked. This is where the packets are getting dropped. So it gives a clear picture what you have to modify if you want to enable the connection between these two applications.
Okay.
So the rules, right? These rules are blocking here.
Got it.
Next hop. So this works in a similar way, like destination IP like 192.168.0.4. We have seen system routes and user-defined routes, right? Uh,
Yes.
uh, in user-defined routes, what I have told, if you want to send all the packets through a firewall, then you will add in the user-defined routes, the next hop is this, like the firewall IP. So here it says system route. That means it is the packets are flowing internally, like within the VNet or within the peering or like that. It is not going through another network virtual appliance, like the firewall or some router where it checks the monitors the IPs. If that is configured, then here it will show the user defined routes and it will say something else. It's not virtual network peering. Here 10.0.0.4 and 192.168.0.4 are two different regions, and the packets are flowing because of this virtual network peering.
Okay.
So effective security rules also you can check uh, to which device or to which resource VM what is applied will change to West US. This will show you which NSG rules are applied on what. If there is a firewall also associated to this, that will also be shown here. So this one has this NSG. Okay, and similarly, VPN troubleshooting, you can use this for troubleshooting VPN connectivity. It can be point to point or site to site. It will ask you few details. So you can provide those details like resource group, location, and all. Then we can troubleshoot. Next is packet capture. Packet capture is something like I want to see uh, what all the requests are flowing through my virtual machines at the port 80. In that scenario, you can use the packet capture. It works similar to Wireshark tool, but this is same as this is on Azure. Wireshark tool is some tool which will do this packet capture thing. It will monitor the packets flowing through particular resource or an instance. Here,
Yeah.
yeah, here, say my virtual machine, and packet capture name is this. I want to save all the packet captured data in a storage account. You can give the storage account details and you can start packet capturing. You can enable, add those details and start packet capturing. So this is another one, connection troubleshoot. You need to provide the source and destination. I can give the virtual machines in East US and virtual machine in West US. If the connections are failing, you can check it from here. Just give the port numbers like these are Linux VMs and diagnostic. It will run the diagnostic and it will provide the details where the packet is dropping, what's the issue. If there are any exception errors, it will show that. So these are the network watcher tools which you can use. Yeah, that's all for the day, Amar. Tomorrow we'll start with VM and VMSS, then also with Azure Entra.
Okay.
Okay, any questions or anything on this? and put
No.
front door.
So I'll just go through again with the comparisons with each and everything. So everything is like all the four what all the traces I have. Each one is working as one this one, right? So one goes the packet capture, one goes the IP tracer, one goes the port blocker, one goes the one verifies the network connection, something like that. So I'll just need to uh, go through which one is what, which one is what again. Yeah, I'll do that.
Okay. What I feel is this security team will be there, right?
Yes.
Especially security team. Uh, I feel that they might be using this tool a lot. I
Yes.
I never use this because we don't go to that situation. As a DevOps engineer, we basically support the developer operations, right? A CI/CD issues or something like that. But these are there, which are available for us also. But we use the frequency of usage is less. But I believe that security team, so their work is mostly on this. The central DevOps team or security team, they might be using that a lot.
Yeah, I think network team would be involved in it and along with the security team because
Hmm.
security team says which need to be blocked, which need to be allowed, and network team gonna be configuring stuff like that. But options were there, right? So I went through your class now. So options were there. I
Mhm.
was little bit in a confusion, which is what, which is what. So that's why I said I'll go back again and just verify things. That's it. Like next hop, NSG diagnosis, IP flow verify. So it's like which one is which one is which in a short form. That's what I wanna do. I'll do that.
Yeah.
Yeah, thank you, Ramesh.
Yeah. Okay, Amar. Okay.
Have a good day.
You too. Yeah. Bye.
Bye.